All right, so today we're going to be talking about something that I think a lot of people overlook. It's not the most exciting topic, but it's super important. We're going to be talking about corrosion on aircraft.
Yeah, it's one of those things that it's not as glamorous as like, aerodynamics or engine performance,
Right.
but it's super critical to the structural integrity and safety of the aircraft.
Yeah, for sure. And you sent over a handbook excerpt, so I'm guessing you're really looking to get into like how corrosion can impact aircraft maintenance.
Yeah, absolutely. I'm just trying to level up my knowledge on this and make sure I'm doing everything I can to prevent it.
Yeah, and that's exactly what we're going to be doing today. We're going to be equipping you with all the knowledge you need to understand the different types of corrosion you need to watch out for,
Right.
the factors that make aircraft vulnerable to it, those kind of tricky areas that are like magnets for corrosion, and of course, the most effective ways to prevent and treat it.
Yeah, because once it gets a foothold, it can be a real pain to deal with.
Yeah, absolutely. And you know what? We're even going to be uncovering the mystery of the smoking rivet. Ever heard of that?
I have heard of it. I don't know exactly what it is, though.
Yeah, we're going to get into that. And plus, you might be surprised to learn just how much where you live plays a role in how often you need to be cleaning your aircraft.
Oh, that's interesting.
Yeah. All right, let's get started. So, first of all, what is corrosion? It's more than just that like rusty look on metal, right?
Yeah, exactly. Um, when we talk about corrosion on aircraft, we're talking about the actual deterioration of the metal. And that can happen in a lot of different ways.
Right.
It's not always going to be as obvious as a big patch of rust. Corrosion can be happening internally, hidden from plain sight.
Yeah.
And that's what makes it so dangerous.
Yeah, and so that's why it's so important to understand like the factors that contribute to corrosion, right? Because if you can identify those factors, you can kind of get ahead of it.
Absolutely. And the handbook excerpt you sent, it actually lists like 11 different factors, which is kind of overwhelming.
Yeah, it is a lot. It's not just one thing. It's usually a combination of things, right? That creates like the perfect environment for corrosion to start.
Right. It's like you need all the ingredients for the recipe to work.
Okay, so let's break it down. What are some of the big players in this corrosion drama?
Well, first and foremost, you have the type of metal itself.
Right. Different metals are more vulnerable than others.
Exactly. Some metals are just naturally more prone to corrosion than others. And then there's the heat treatment.
Oh, so like how the metal was treated during manufacturing.
Exactly. The way a metal is heated and cooled during manufacturing can actually change how susceptible it is to corrosion. So that's something that's being considered even before the aircraft is even built.
So they're thinking about corrosion from the very beginning.
Absolutely. And then you have things like dissimilar metals coming into contact with each other.
Right.
Think about steel fasteners on an aluminum sheet.
Oh, yeah, that's a classic recipe for trouble.
Yeah, and that can accelerate the corrosion process because you have these two metals that are
Yeah.
basically battling it out.
Right. It's like they're in a little war and the corrosion is the battlefield.
Exactly. And then you have the environment,
Right.
temperature, humidity, exposure to salt water or industrial fumes. All of these things can significantly speed up the corrosion process.
That's a lot of things to think about. There's a map in the handbook, figure 8 to 3, I think,
Right.
that shows the corrosion severity in different parts of North America.
Yes, the North America corrosion severity chart. That's a great visual representation of how much your location can influence the rate of corrosion.
Yeah, it's really interesting to see how much it varies depending on where you are.
Right. So if you're operating an aircraft in a coastal region, for example, or an area with a lot of industrial activity, you're going to need to be extra careful about corrosion.
Yeah, that makes sense. Okay, so we've got all these factors that make aircraft vulnerable, but how does corrosion actually happen? What's the process?
Well, the handbook breaks it down into two main types. There's direct chemical attack, and then there's electrochemical attack.
Okay, so tell me about direct chemical attack.
Direct chemical attack is kind of like a brute force attack. It's when a corrosive agent directly contacts the metal surface and starts eating away at it.
Oh, okay, so give me an example.
So imagine battery acid spilling onto a metal surface.
Right.
That acid is going to react with the metal directly, and that's going to cause immediate damage.
Okay, so that's a pretty obvious one. Are there any like less obvious examples of direct chemical attack?
Yeah, even something as seemingly harmless as like leftover flux residue from welding.
Oh,
If it's not cleaned properly, it can become a corrosive agent.
so it's really important to pay attention to those little details during maintenance.
Absolutely. Now, electrochemical attack is a little bit more subtle. It's not as in your face, but it can be just as damaging over time.
Okay, so how does that one work?
It's all about the flow of electrons between different metals. It's
Mm.
kind of like a tiny battery forming on the surface of the metal.
Oh, wow.
And you need four things for this to happen. You need an anode, a cathode, an electrolyte, and an electrical connection between them.
So it's like a mini circuit happening right there on the metal.
Exactly. And the nobility of the metals involved determines which one is going to become the anode and corrode.
Nobility.
Yeah, it's a term that describes how easily a metal gives up electrons.
Okay. So the less noble a metal is, the more likely it is to corrode.
Exactly. And the handbook actually has a chart, figure 8.6, the galvanic series chart. It shows the nobility of different metals.
Oh, that's interesting.
Yeah, it can be really helpful for understanding how different metals are going to interact in terms of corrosion.
So we've got these two main types of attack, but corrosion can actually take many different forms, right?
Yeah, absolutely. And being able to recognize the different forms of corrosion is really important for catching it early on.
Okay, so let's talk about some of the different forms. What's one of the most common ones we see on aircraft?
Well, one of the most common forms is surface corrosion.
Okay, and that seems pretty straightforward, right? Just corrosion on the surface of the metal.
It is, but that's what makes it dangerous.
Oh, how so?
Because people see a little surface rust and they think, oh, no big deal.
Right.
But the thing is, surface corrosion can actually be hiding much more serious damage underneath.
Oh, so it's like the tip of the iceberg.
Exactly. So it's
Okay.
really important to pay attention to any changes in the surface texture.
Like what kind of changes?
Things like roughening, pitting, blistering paint. Those are all signs that something might be going on beneath the surface.
Okay, so don't be fooled by a little surface rust. There could be a whole lot more going on underneath.
Right. Now, another form of corrosion that we see pretty often is filiform corrosion.
Filiform corrosion. That's a new one.
Yeah, it gets its name from the Latin word filum, which means thread,
Oh.
because filiform corrosion leaves these distinctive worm-like traces under the paint.
Oh, that's interesting.
Yeah, it almost looks like little tunnels. Figure 8 to 8 in the handbook gives you a good visual of what it looks like.
Oh, wow. Yeah, that is pretty distinctive. It's kind of amazing how these different forms of corrosion have their own unique look, you know?
Yeah, exactly. And that's why it's so important to be familiar with them.
Hmm.
Because once you know what to look for, you can spot these problems early on.
Right. Okay, so we've got surface corrosion, which can be deceptive.
Right.
And we've got filiform corrosion with its little worm-like trails. What else should we be on the lookout for?
Well, one of the most insidious forms of corrosion is pitting corrosion.
Pitting corrosion. What makes it so insidious?
Well, pitting corrosion creates these tiny little pits in the metal surface.
Right.
And they might seem harmless at first, but those pits can actually penetrate very deep into the metal,
Oh, wow.
causing significant damage that's not immediately obvious from the surface.
Yeah, figure 8 to 9 in the handbook shows how those pits can be much deeper than they appear on the surface.
Exactly.
That's a little scary.
It is. And that's why it's so important to catch it early on.
Yeah, for sure. Now, what about when you have different types of metals in contact with each other? Does that cause problems?
It can. That's what we call dissimilar metal corrosion, or sometimes it's called galvanic corrosion.
Oh, okay.
And it happens when two different metals are in direct contact with each other.
Right.
And they create this galvanic reaction that can actually accelerate the corrosion process.
Oh, I see. So it's like those two metals are fighting, and the corrosion is the result of that fight.
That's a good way to put it. And that's why it's so important to use the right type of fasteners for different materials.
Right.
For example, you never want to use a steel fastener on an aluminum sheet.
Right, because the aluminum is going to corrode much faster.
Exactly. The aluminum is less noble than the steel, so
Yeah.
it becomes the sacrificial lamb in that galvanic reaction.
Okay, so you want to make sure those metals are compatible.
Exactly. And figure 810 in the handbook actually shows a really good example of what dissimilar metal corrosion looks like.
Okay, so dissimilar metal corrosion is all about those direct metal-on-metal interactions. Are there any other kind of tricky situations that can lead to corrosion?
Yeah, there's another type of corrosion called concentration cell corrosion.
Concentration cell corrosion, okay.
And this type of corrosion is all about tiny variations in the environment surrounding the metal.
Okay, like what kind of variations?
Things like differences in metal ion concentration or oxygen concentration.
Yeah.
And these variations can create little cells where corrosion is more likely to occur.
So even subtle differences in the environment can trigger corrosion.
Exactly. It's all about those little microenvironments that form on the metal surface.
So where are these concentration cells most likely to form?
Well, one common place is under faying surfaces where solutions can stagnate.
Faying surfaces.
Yeah, think about areas where two pieces of metal are joined together,
Mm-hmm.
and there's a little gap that can trap moisture.
Oh, okay.
Figure 811 shows a good example of that.
Okay, so those little gaps and crevices can be real trouble spots.
Exactly. And another place where concentration self-corrosion can occur is in areas with restricted oxygen diffusion.
Restricted oxygen diffusion.
Yeah, basically areas where the oxygen levels are lower.
Oh, okay.
Figure 812 highlights some of those areas.
Okay, so it's all about understanding how those tiny variations in the environment can create those little corrosion hotspots.
Exactly. Now, what about those metals that have a protective oxide film on them, like aluminum, for example?
Right, aluminum has that natural oxide layer that helps to protect it from corrosion.
Right. But even those metals can corrode under certain conditions.
Really?
Yeah. And that's what we call active passive cells.
Active passive cells. Okay.
And it happens when that protective oxide film gets damaged.
How does it get damaged?
It could be something as small as a dirt particle or a scratch or a little bit of abrasion.
Oh, I see.
And when that passive film is damaged, it exposes the active metal underneath,
Right.
and that makes it susceptible to corrosion.
Okay. So even though it has that protective layer, it's still vulnerable if the layer is compromised.
Exactly.
Mm.
And figure 813 shows how that pitting can occur when the passive film is damaged.
Wow. Yeah. So it's really important to keep those surfaces clean and free of any contaminants that could damage that passive film.
Absolutely. Now, there are also some forms of corrosion that actually attack the grain boundaries of the metal.
The grain boundaries.
Yeah, so every metal is made up of these tiny little crystals or grains.
Right.
And the boundaries between those grains are a little bit weaker than the grains themselves.
Oh, okay.
And there's a type of corrosion called intergranular corrosion that specifically attacks those grain boundaries.
So it's like it's eating away at the metal from the inside out.
Exactly. And it's often hidden from view, so it can be really difficult to detect.
And that sounds really dangerous.
It is. And if it's not caught early, it can lead to something called exfoliation corrosion.
Exfoliation.
Yeah, and that's when layers of the metal actually start to peel away from each other.
Wow. Figure 815 shows a pretty dramatic example of exfoliation corrosion. Definitely not something you want to see on your aircraft.
Definitely not. Now, we've also got to consider the role of stress in corrosion.
Stress.
Yeah, when metal is under stress, it's more susceptible to corrosion.
Okay, so like parts of the aircraft that are under a lot of load.
Exactly. And there's a specific type of corrosion called stress corrosion cracking.
Oh, okay.
And that occurs when you have metal that's under stress and it's exposed to a corrosive environment.
So it's like the stress is weakening the metal, making it more vulnerable to attack.
That's a good way to think about it.
Yeah.
And stress corrosion cracking can lead to cracks forming in the metal. And those cracks can propagate and eventually lead to failure.
Yeah, figure 816 in the handbook shows how serious that can be.
Right. Now, similar to stress corrosion cracking, we have fatigue corrosion.
Fatigue corrosion.
Yeah, and this happens when you have repeated stress cycles.
So think about parts of the aircraft that are constantly moving or vibrating.
Exactly. And just like with stress corrosion cracking, the presence of a corrosive environment just makes the problem worse.
Right, so it's the combination of the stress and the corrosive environment that's really dangerous.
Exactly. And then there's one more type of corrosion I want to mention. It's called fretting corrosion.
Fretting corrosion.
Yeah. And this happens when you have slight relative motion between two surfaces.
Oh, okay, so like parts that are bolted or riveted together?
Exactly. And that tiny but constant rubbing action can wear away at those protective coatings.
Right.
And it can create these little pits and debris. And figure 817 shows a classic example of what fretting corrosion looks like.
Okay, and isn't this where we finally get to the smoking rivet?
Ah, yes. The smoking.
That was one of the things I was really curious about.
Yeah, so that black ring that you sometimes see around a rivet, that's a telltale sign of fretting corrosion.
Oh, interesting. So it's like the rivet is literally sending up a smoke signal saying, hey, there's something wrong here.
Exactly. So if you see a smoking rivet, you know that you need to investigate further.
Okay, so we've covered a lot of ground here. We've talked about direct chemical attack, electrochemical attack, and all these different forms of corrosion.
Right.
It's pretty amazing how many ways corrosion can manifest itself.
It is. But now that we have a good understanding of the enemy, we can start talking about how to fight back.
Right, because all of this is pretty daunting, to be honest. It seems like corrosion is this constant threat.
It is.
Huh.
But there are a lot of things we can do to prevent it and to control it. So let's talk about some of those strategies.
Yeah, let's get into that. What are some of the main things we can do to protect our aircraft from corrosion?
Well, the first line of defense is preventive maintenance.
Okay, so like keeping the aircraft clean and well lubricated.
Exactly. And that means more than just a quick wash and wax.
Right.
We need to be really meticulous about cleaning those areas where corrosion is most likely to occur.
Like those battery compartments and bilge areas we talked about earlier.
Exactly. And we need to make sure we're using the right cleaning agents and techniques.
Right, because as we learned, even some cleaning agents can actually contribute to corrosion if they're not used properly.
Exactly. And then lubrication is also really important.
Oh, yeah, because a good lubricant can help to create a barrier between the metal and the corrosive agents, right?
Exactly. But it's not just about creating a barrier. Lubrication also helps to reduce friction,
Right.
which can actually worsen corrosion in some cases.
Okay, so cleaning and lubrication are like the foundation of corrosion prevention.
Right. And then the next most important thing is inspection.
Right, regular inspections.
Exactly. We need to be inspecting those aircraft regularly and thoroughly, and we need to train our eyes to spot those early signs of corrosion.
Like those changes in the surface texture we talked about earlier.
Exactly. And the handbook actually mentions using mirrors, borescopes, fiber optics,
Right.
all sorts of tools to help us see those hard-to-reach areas.
It's like being a detective looking for clues.
Yeah, that's a good way to think about it. Now, sometimes those visual inspections aren't enough,
Yeah.
and we need to use some more advanced NDI methods like liquid penetrant testing or eddy current testing.
Right, those non-destructive inspection methods.
Exactly. But those require specialized training and equipment.
So it's kind of a combination of good old-fashioned visual inspection
Right.
and those high-tech methods when necessary.
Exactly. And we need to be smart about where we're focusing our inspection efforts.
Right, because as we talked about, there are certain areas on the aircraft that are more prone to corrosion than others.
Exactly. So let's talk about some of those corrosion hotspots.
Okay, let's do it. Where do we start?
Well, let's start with one of the harshest environments on the aircraft,
Yeah,
the
that.
engine area.
Okay, that makes sense. Those engines are working hard, generating a lot of heat and exhaust.
Right. And those exhaust trail areas are constantly bombarded with corrosive deposits.
So we need to be paying close attention to those areas.
Absolutely.
Hmm.
And that includes not just the engine itself, but also all those surrounding components.
Right, like the cowlings and the mounts.
Exactly. And figure 819 in the handbook actually highlights that exhaust trail area and shows you some of the things you should be looking for.
Okay. What about the battery compartments? We talked about how battery acid can be a major corrosive agent.
Yeah, battery compartments are definitely a high-risk area, so we need to be inspecting those regularly for any signs of leaks or fumes.
And checking the condition of the battery box itself.
Exactly, because even a small leak can cause big problems down the road.
Yeah, for sure. What about those bilge areas? Those areas where fluids tend to collect.
Yeah, bilge areas are another common spot for corrosion, so we need to make sure those are being cleaned and inspected regularly.
Right, out of sight, out of mind, but definitely not out of danger.
Exactly. And then there are those areas where spills and moisture are more common.
Right, like lavatories and galleys.
Right. Because even if the spilled substance itself isn't corrosive,
Right.
it can create an environment that's more conducive to corrosion.
Okay, so it's all about understanding how those little things can contribute to the bigger problem.
Exactly. Now let's move on to the landing gear.
The landing gear.
Yeah,
Okay.
because the landing gear is exposed to all sorts of stuff, right?
Hmm?
Rain, snow, slush, salt spray.
Right, it takes a beating.
Yeah. And figure 820 in the handbook really shows how vulnerable the landing gear is.
So what should we be looking for specifically when we're inspecting the landing gear?
Well, the wheel wells are particularly tricky
Okay.
because they're hard to keep clean,
Right.
and it's tough to maintain a good paint coating in there.
Right.
So we need to be checking for any signs of paint damage, chipped areas, exposed metal, anything that could allow corrosion to get a foothold.
Okay. And the brake assemblies are getting a lot of wear and tear too.
Exactly. And then you have those engine frontal areas
Okay.
where the cooling air is sucked in.
Right.
Those areas are exposed to everything the atmosphere throws at them, especially during takeoff and landing when debris is getting kicked up.
Right. Right. So we need to be inspecting those areas for any signs of damage or debris buildup.
Exactly. And then you have those hidden nicks and crannies like the wing flap and spoiler recesses.
Right, those areas where it's easy to forget about.
Yeah, those areas can trap moisture and dirt,
Right.
which creates that perfect environment for corrosion.
Okay. And what about the external skin of the aircraft? It seems like that would be pretty easy to inspect, right? Because it's right there in front of you.
You'd think so, but there are some tricky spots.
Oh, okay. Like what?
For example, those piano hinges.
Piano hinges.
Yeah, those hinges that run along the control surfaces.
Right.
Those are notorious for corrosion.
Why is that?
Well, first of all, you often have dissimilar metals in contact with each other in those areas.
Right, because the hinge itself might be made of a different metal than the skin.
Exactly. And secondly, Those hinges can trap contaminants really easily.
Oh, I see. So it's like a double whammy.
Exactly. And figures 821 and 822 in the handbook actually show you why those areas are so susceptible to corrosion.
Okay, so we need to be paying extra attention to those piano hinges, making sure they're clean and lubricated.
Absolutely. And then you have those electronic and electrical compartments.
Right.
Those are really sensitive to moisture.
Yeah, because moisture can cause all sorts of problems with electrical systems.
Exactly. So we need to make sure those compartments are properly sealed and that any drainage paths are clear.
Right, we don't want any water pooling up in there.
Exactly. So basically, nowhere on the aircraft is immune to corrosion.
Yeah, it sounds like it. It's a constant battle.
It is. But the good news is that we have the tools and the knowledge to fight that battle effectively.
Right. So vigilance is key.
Absolutely. But even with the best preventive measures in place, corrosion can still happen.
Right.
So let's talk about what to do when we find it.
Okay, let's get into that. What are the main approaches to corrosion removal and treatment?
Well, there are two main methods: mechanical removal and chemical removal.
Okay, so mechanical removal, that's basically like physically removing the corrosion, right?
Yep. Using tools like abrasive papers, power buffers, non-woven pads. Figure 828 in the handbook actually shows some of those.
Oh, yeah, those non-woven pads. I've seen those used before.
Yeah.
So is there like a specific type of pad for each type of corrosion?
Not necessarily. The choice of pad depends more on how bad the corrosion is and the surface you're working with.
Right.
But the important thing is to use the right grit,
Mm-hmm.
and technique to remove that corrosion without damaging the metal underneath.
Right. You don't want to make the problem worse.
Exactly. Now, with chemical removal, you're using special solutions to, well, basically dissolve the corrosion.
And that sounds a little bit riskier to me.
It can be.
Is there a chance that those chemicals could actually damage the metal if they're not used properly?
Yeah, there's always a risk with chemical removal.
Right.
It's super important to use the right chemical for the specific metal you're treating
Okay.
and to make sure you rinse away all the residue afterward.
Right. You don't want those chemicals hanging around and causing more problems.
Ex-
Okay, so caution is key with chemical removal. What about the general steps involved in treating corrosion? Is there like a standard procedure?
Yeah, it usually involves cleaning the area first, getting rid of any coatings.
All right, so you're starting with a clean slate.
Exactly. Then you remove the actual corrosion and you neutralize any chemicals that are left over.
Okay.
And finally, you apply those protective coatings.
Right, to prevent it from coming back.
Exactly.
Okay, so it's a multi-step process and each step is important. But does the treatment vary depending on the type of metal you're dealing with?
Absolutely. Each metal has its own, well, quirks. For example, with ferrous metals like steel, the main thing is getting rid of all the rust.
Right, rust is the enemy.
It is.
Yeah.
And you got to be careful not to embed any iron oxide into the surface
Okay, why is that?
because that can actually speed up future corrosion.
Oh, interesting. So no shortcuts when it comes to rust removal.
Nope. What about aluminum alloys?
Yeah, what's different about treating aluminum?
Well, with aluminum, it depends on if it's painted or not.
Oh, okay.
And it's really important to protect that alclad layer.
The alclad layer, remind me what that is again?
Oh, it's a thin layer of corrosion-resistant aluminum that's bonded to the base metal.
Right, right. So it's
Yeah.
like an extra layer of protection.
Exactly. And if that alclad layer gets damaged, the metal underneath is much more vulnerable.
Makes sense. So we need to be extra careful when we're working with aluminum, especially if it's alclad. What about magnesium alloys? Those are pretty reactive, right?
Oh, yeah. And with magnesium, speed is key. You want to treat that corrosion quickly and carefully.
The handbook specifically warns against using metallic tools on magnesium. Why is that?
Because those metallic tools can actually embed themselves in the magnesium.
Really?
Yeah, and that can make the corrosion worse.
Oh, wow. So it's best to stick with non-metallic tools for magnesium.
Yep. Now, what about titanium?
Yeah, titanium. I know it's known for being very corrosion resistant.
It is. But even titanium can corrode under certain conditions. The tricky thing is that it can be hard to spot corrosion on titanium.
Oh, so we need to be extra vigilant.
Exactly. And we have to use special cleaning methods. And you definitely don't want to use steel tools on titanium.
Right, because the steel can contaminate the titanium.
Exactly.
Okay, so each type of metal has its own set of rules when it comes to corrosion treatment. What about when you have different metals in contact with each other? How do you prevent that galvanic corrosion from happening?
That's where those protective separators come in. You can use things like primers, tapes, sealants, basically anything to create a barrier between those metals. Figure 830 in the handbook gives you a good overview of which metals need to be separated.
Okay, so you're basically isolating those metals from each other.
Yeah. Now, once you've identified the corrosion, removed it, and treated the area, what's next?
Yeah, how do you decide if a repair is necessary or if the part needs to be replaced?
That's where those damage classifications come in. The handbook outlines 4 categories: negligible, repairable by patching, repairable by insertion, and replacement.
Okay, so you're assessing the severity of the damage.
Right. And even with what seems like negligible damage, you still need to clean it, treat it, and protect it.
So you're not ignoring it no matter how small it is.
Exactly. And when you do need to make a repair, it's really important to fair and blend those reworked areas. Figures 823, 824, and 825 show you what I mean.
Okay, so you're making sure those repairs are smooth and seamless.
Yeah. And that's not just for looks. It's about getting rid of any stress risers that could lead to future problems.
Okay, so we've covered corrosion removal, treatment, and repair. But how do we prevent this whole mess from happening in the first place? What are some of those key processes and materials that go into corrosion control?
Well, it all starts with the metal finishing processes that are used during manufacturing. Things like cleaning, pickling, plating, polishing, all of those help to create that initial barrier against corrosion.
Right, so they're already thinking about corrosion from the very beginning.
Absolutely. And then there are all sorts of chemical treatments that can enhance the metal's natural resistance to corrosion.
Okay, like what?
Well, anodizing, for example.
Anodizing, yeah.
That creates a really durable oxide film on aluminum, makes it much more resistant to corrosion.
Right. And it's important to know how to properly clean and maintain those anodized surfaces, right?
Absolutely. Then there are conversion coatings, like bondrite, which create a protective layer on the metal surface. And then there are inhibitors.
Inhibitor.
Yeah, like chromic acid.
Oh,
Those help to passivate the metal,
passive fade.
basically slow down the corrosion process.
Okay, so it's like giving the metal a little bit of a shield.
Exactly. But even with all these fancy chemical treatments, nothing beats a good, intact paint finish.
Right. The paint is like the first line of defense. If figure 831 in the handbook really shows how effective that can be.
Yep, it's like armor for the aircraft. And choosing the right type of paint is important too. Those catalyzed polyurethane enamels, the waterborne polyurethanes, the epoxies, those offer excellent protection. And with all the VOC regulations these days, those waterborne systems are becoming more and more popular.
Right, right. So we've got our protective coatings in place, but it seems like maintaining that cleanliness is an ongoing battle.
It is. Aircraft cleaning isn't just about looks. It's a crucial part of corrosion control.
Right. So what are some of the main methods for keeping those aircraft sparkling clean?
Well, you got your wet wash, your dry wash, and your polishing.
Okay, so break those down for me.
Wet wash is your traditional soap and water approach, but you often use special cleaning compounds designed for aircraft.
Okay.
Dry wash is for when you can't use water.
So like if you're in a desert environment.
Exactly. Or somewhere where water is scarce.
Right.
And it's also good for removing light dirt and grime. And then polishing is all about restoring that shine and removing those stubborn stains and oxidation.
Okay, so each method has its pros and cons. Are there any general things we need to keep in mind when we're cleaning aircraft, regardless of the method?
Yeah, for sure. You always want to work in the shade if possible.
Okay, why is that?
You don't want those cleaning solutions drying too quickly.
Right, because that could leave streaks.
Exactly. And it's really important to protect any openings, like engine intakes and static ports, from water and cleaning solutions.
Right, we don't want any of that stuff getting into sensitive areas.
Whoop. And when you're cleaning those flat finishes and plastics, you got to be gentle.
Okay, so don't scrub too hard.
Exactly.
Okay, good tips to remember. What about cleaning the interior of the aircraft? That seems like it could be a bit more challenging.
It can be. You're working in tight spaces, and there's always the risk of trapped debris causing corrosion. The handbook recommends using non-flammable cleaning agents whenever possible.
Okay, so things like detergents, soaps, alkaline cleaners, those would all be good options.
Yep, they're effective, and they don't pose a fire hazard. But there are some flammable cleaning agents that you might need for certain tasks.
Right, like those high flash point solvents the handbook talks about.
Yeah, those require extra precautions.
Mm-hmm.
Ventilation is crucial, and you have to be super careful handling those flammable liquids. The section on container controls and fire prevention in the handbook is a must-read.
Okay, safety first. Always a good reminder. What about cleaning the power plant? Is that something that requires a specialized approach?
It does. It's not just about aesthetics. It's about maintaining engine efficiency and spotting any hidden defects. You usually have to open up those cowlings and give everything a thorough cleaning with kerosene or an approved solvent.
Okay, so it's a more involved process.
Yeah. And then there's propeller and rotor blade cleaning, which requires a really delicate touch. You got to avoid those harsh materials that could damage those blades. And you need to pay attention to any leading edge pitting, which could be a sign of corrosion.
Okay, so each part of the aircraft has its own little cleaning quirks.
Right. And finally, let's talk about those solvent cleaners that are so commonly used in aviation.
Okay, solvents.
You've got your Stoddard solvent, your aliphatic and aromatic naphthas, your safety solvents, MEK, kerosene. They all have their specific uses.
So how do you know which solvent to use for a particular task?
That's where the safety data sheet, or SDS, comes in.
Hmm.
You got to read the SDS for any solvent you're using to understand its properties, its flash point, its toxicity.
Right, right. All the safety information.
Exactly. And it'll tell you about any special precautions you need to take, as well as its impact on the environment.
Okay, so the SDS is like our guide to using solvents safely and responsibly.
Exactly.
Well, this has been a whirlwind tour of aircraft cleaning. From those gentle techniques to those heavy-duty solvents, it's clear that keeping those aircraft clean is a crucial part of the corrosion battle.
It is.
We've really covered a lot of ground in this deep dive. We've explored what aircraft corrosion is, those sneaky ways it hides, all the factors that contribute to it, those pesky corrosive agents, and the whole arsenal of preventative measures and treatments we have at our disposal.
It's a lot to take in.
It is. But the good news is that with knowledge comes power. The more we understand about corrosion, the better equipped we are to fight it.
Absolutely.
So the key takeaway here is that corrosion is a constant threat.
It is.
But by understanding the forms it takes, the causes, and the prevention methods, you can protect your aircraft and keep them flying safely.
Exactly. Never underestimate the importance of staying informed. The world of corrosion is always changing, so make sure you're keeping up with those new materials and techniques.
Right. It's about being a lifelong learner.
It is. Your aircraft's structural integrity depends on it.
Well said. So, armed with this knowledge, you're ready to take on corrosion and win.
You got this.
Keep those inspections regular, those services clean, and fly safe, everyone.